In this video, I will show you how to use graphs to solve something complicated like 2 to the power of x equals 5. So in order to solve this here, try to draw this graph here and then draw this graph here and then find out where, well, let's draw this graph first. So this graph here, 2 to the power, 2 to the power of x will look something like this, okay? And if you draw a graph of y equals 5, it will basically just be a horizontal line going through 5. Now if you are trying to solve this, 2 to the power of x equals 5, well, if you look at this bit here, this graph here represents everything. Well, this graph represents 2 to the power of x. So this graph here represents 2 to the power of x. Now, if you want to find out where this equals this, well, where this equals this, well, it would be at this point here, because everything on this line here represents 2 to the power of x. Now, when 2 to the power of x gets here, it equals 5. And if you look at this line here, 2 to the y equals 5 is always 5. So, well, if you want to find out where 2 to the power of x equals 5 is going to be the point of intersection, or the point where the two lines cross. Because this line here represents everything about this 2 to the power of x. So when it gets to here, it's 5. And if you look at this line here, it's 5 at this point as well. So if you want to find out where this line where this equals this, it's going to be at this point here. So basically, at this point here, you would go all the way down here, and then the answer would be x would be roughly 2 point something, okay? Because 3 is here. So you know the answer to this x here will lie between 2 and 3 from this graph, okay? Because 3 is here, somewhere here, and then 2 is here. The point of intersections is in between 2 and 3, so it's somewhere in between, okay? So okay, so if you want to try and solve this here, let's imagine we didn't have this graph to help us, okay? So let's try and solve this from scratch. So in order to solve 2 to the power of x equals 5, well, start by drawing this graph here. So I've done many videos on this. So if you don't know how to sketch this, then you might have to scroll back and watch some of the early videos. So 2 to the power of 0, that equals 1. So let's say 1 is here. Now as you increase x, it will grow exponentially. So it will grow very fast. Now as you increase x in a negative direction, it will head towards 0. It gets smaller and smaller and smaller. It will head towards 0. Okay. So hang on. Let's start again here. 2 to the power of x equals 5. So if you try and plot this, it will look something like this. 1 will be around here. So it will be something like this. Hang on. Well, let's say 1 is here. Let's say 1 is here. So let me erase this. Okay, so this graph is y equals 2 to the power of x. Now, if 1 is here, 2 is here, 3 here, 4 here, 5 here. So try and sketch this y equals 5. So it will be a horizontal line going through 5. Okay, so start by sketching y equals 2 to the power of x, which is this curve here. Now, if you want to solve this equals this, then it's going to be the point of intersection here. It's going to be where the two lines equal each other. Now, you don't know where, well, from up here, you know it's between 2 and 3. But let's pretend we didn't have this line here, this graph here. So you know it crosses here, but you don't know where this point is. It could be between, let's say, 30 and 31. You don't know that. So well, because you don't know that, then create a table like this. Okay. So here, start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. And then put So we are trying to investigate 2 to the power of x equals 5. And then this third row here is always 5. It's y equals 5. It's always 5. 5 all along here. Okay? And so on. Now put 0 into this x here. 2 to the power of 0. This will be 1. Okay? Now put 1 into here. It's going to be 2 to the power of 1 will be 2. Okay? And put this into here. 2 to the power of 2. That would be 4. You see? Oh, okay. And then put 3 into here. This would be 2 to the power of 3. That would be 8. You see, but by looking at this table already, you know that it crosses between 2 and 3 because, well, from our rough sketch earlier, it's something like this. Okay, let's just imagine this is y equals 5. This is y equals 2 to the power of x. Now, if you look at 2, let's say 2 is here. Okay, so let's say 2 is here. Now, 2, you see this graph here, 2 to the power of x, is below 5. 5 is here. Okay, 5 is up here. Now, this bit here, the 5 here, represents this bit here. Now, 4 here represents this point here. You see, at the moment, 4 is below 5, so we haven't crossed it yet. Now, if you look at 3, 3 is here, let's say here. Now, 3, this value here is 8. It's actually miles above 5. So let's just say 8 is around here. Let's just say this bit is 8. My point is that well, hang on, 8 here represents this bit here, and 5 here represents the represents this bit here. Okay, 5 represents here. So 5 here represents this bit here. Okay, now look at this here. Keep an eye inside your mind. Keep an eye on inside your mind. Remember 2 to the power of x. Keep an eye on 2 to the power of x here. When x equals 2, y equals 4. So it's below 5. And when you get to 3, it's above 5. So you know it crosses somewhere in between. Okay, so because there's a crossover here, because at the moment it's 4 below 5, and then when it gets to 3, it jumps to 8 above 5. So you know it crosses in between 2 and 3. Okay, so now you can zoom in. You can zoom in and create something like this, because you know it crosses between 2 and 3. Then create lots of different. Then basically zoom in and create a table like this. You know it crosses between 2 and 3, so we won't bother doing 2 and 3 here. Let's just investigate all these values in between. Remember, it's all 5 here. Okay, 5, 5, 5, 5, 5, and let's find out where the 2. Well, 2.1 I predict is still below 5. Okay, so let's get a calculator out and do 2 to the power of 2.1. Okay, because we are trying to investigate 2 to the power of x equals 5. We are trying to find out a value of x where this side equals this side here. So let's put this into this bit here. So 2 to the power of 2.5. Let's clear this. Where's clear? Clear. So 2 to the power of 2.1 equals 4.29, say. Okay, 4.29. Was that right? Yeah, 4.29. You see, this value here is below 5 at the moment. Okay, so you can imagine it to be somewhere around here. It's below 5. Now let's look at 2.2. So now we are looking at 2 to the power of 2.2. So we are basically putting this into this x here. So now 2 to the clear this. 2 to the power of 2.2 equals it's still below 5. So 4 equals 4 point what? 4.59. 2.59. Okay. Now put the 2.3 into this thing here. So we are now looking at 2 to the power of 2.3. So clear 2 to the power of 2.3. Sorry. 2 to the power of 2.3 equals 4.92. So 4.92. You see, it's still below 5. So on our graph, on our sketch, it looks something like this. It's still below 2 point, so it's still below 5. So now put 2.4 into here. So now let's investigate 2 to the power of 2.4. So calculator, clear 2 to the power of 2.4 equals. Oh, now it's above 5. It's 5.28. 5.28. So here, this point here is somewhere above the 5 mark. So you know here it crosses between 2.3 and 2.4. So let's just say x is roughly 2.3. Okay. Yeah, let's just say it's between 2.3 and 2.4. When you're using graphs to find out something like this, you can only guess roughly. So we're going to guess it's definitely not 2.2 because it's in between 2.3. So looking at our original this original graph here, which was done by a graph plotter. So you can guess that this bit here is roughly 2.3, roughly. We can only guess roughly when we use graphs. Okay.